Hello, everybody. So I'd like to welcome you all to our latest NextSpace session. My name is Sam. I'm the head of marketing and growth here at Reflex Aerospace, and I will be your host for today. So this series we're running is all about a simple but highly important topic, which is space is critical infrastructure. In this episode, we're focusing on next-gen communications and why it matters for sovereignty, resilience, and transatlantic cooperation. I'm joined today by a few folks from Reflex Aerospace and CesiumAstro who bring perspectives spanning technology development, cybersecurity, and European-US space collaboration. Over the next 30 minutes, we're going to be digging into some of the stakes here, what sovereign space infrastructure really means, how the latest communications technologies are changing the game, and how startups can thrive in a rapidly maturing ecosystem. So I don't want to take up too much of the time here. I'd rather get it all to you. So thank you for joining. Could you all start by giving a brief introduction of yourselves?
Sure. Let me start maybe. I'm Dennis Moore. I'm Chief Commercial Officer here at Reflex. Reflex is a satellite manufacturer in Berlin and Munich. So for now, we are fully German, a German company. I have a background in aerospace engineering. However, right after graduation, I already pivoted towards the commercial side of things. I started in the aviation sector and then eventually crossed over to the space sector. Since 2018, I was then involved with a company called CesiumAstro back then. It got bought over by CGI, a big Canadian consulting company. And there the focus was on ground systems, monitoring and control solutions, big data centers, so everything that supports a space mission on the ground. And my main focus was on MilSatcom and GovSatcom related topics. So I won one of the projects that helped CGI to develop a pooling and sharing system for European secure communications. Back then, it's mostly communications served by the more conservative providers that have their geo satellites in space. But now it is that the trend goes towards LEO SATCOM constellations, distributed systems, not like big monolithic systems in space. And here at Reflex, I joined Reflex 3.5 years ago. We are trying to enable this kind of new thinking, this kind of modern technology, if you want, by producing the satellite platforms that then host payloads for the customer to really enable them to serve their mission to the fullest.
All right, well, maybe we move on to Sotiria next.
Yeah, of course. Thanks a lot for having us, Dennis and Sam. My name is Sotiria Stathopoulou. I'm a product manager with CesiumAstro. CesiumAstro is a company that makes active phased arrays for space, air, and ground. But we are also expanding our activities in many other areas. I'm based out of Munich, so we have an office in Germany, and I lead the activities here. I focus, along with Iraklis, on expanding our presence in Europe. My work, and I'm an engineer by background. I studied electrical engineering. I was working in RF communication for terrestrial networks, and then I moved into the space industry where I was working for some geo operators at the time out of the US. And then I quickly moved into startups and innovative products for satellite communication, like optical terminals for inter-satellite links or space-to-ground links. And now with CesiumAstro from the RF side and the active phased arrays, which really is a very innovative product for space. So yes, here in Europe, we are focused on developing these advanced communication payloads for customer missions and helping generally shape these solutions to meet Europe's growing space infrastructure. And I'm very glad to be here today, and I can wait for the discussion.
Yep.
Thank you. And finally, I am Iraklis Hatziathanasiou. I am the Senior Director of Business Development for CesiumAstro. As Sotiria mentioned, my main task is to grow the presence of CesiumAstro in Europe. both from a perspective of capabilities, skills, and possibly manufacturing as well. My background is in spacecraft communications. I've been working for the space industry for well over 30 years now. And I have seen how the industry has evolved over this period of time. I have worked for Canadian companies, for startups, CubeSat companies. I even had my own company at some point. So I have a wide, let's say, view of how the industry has evolved and where it stands at the moment. I'm very happy to be in this conversation, and I'm looking forward to throwing some of my ideas and experience into this conversation as well. Thank you.
Well, we are very happy to have all of you on this call today. So I think it's important to set the stage here and maybe help our listeners understand the stakes of the issue and what we mean when we talk about resilient, sovereign space infrastructure. What is that, and why should we care about it?
So from our perspective, resilience comes with the number of systems in space, for and foremost. If you have distributed systems and one or a few nodes will not work anymore, you still have a large number of other satellites that can take over, and the overall performance of the system is not affected that much. It is not so much the resilience in the components itself. We are a NewSpace company. We want to keep that NewSpace spirit, but also the value of NewSpace systems in space. And that means reducing the requirements on the components itself, therefore reducing the overall cost for the customer and allowing to produce more equal systems that then take over one mission. And sovereignty, we do live in turbulent times. Sovereignty is something that is getting more and more important, and it's a term that is used more and more also on the global politics stage. Sovereignty is important because, either you're a country or like the European Union, you're a group of countries, you need access to your space capabilities that no one else can interrupt, and that it's no one else's liberty to say if you're allowed to continue to use it or not. And that's just a part of sovereignty, but for us, that's the most important part. And as Reflex, we have the mission to allow everyone to own their own sovereign assets and use them to their fully extent for you, so that you have highest priority in terms of using it.
Yeah, I think that's a great answer. Sotiria, Iraklis, do you have anything to add to that?
Of course. I think those two terms, resiliency and sovereign capability, are very closely linked nowadays. Obviously, every country, every continent wants to have their own capabilities in terms of being able to tackle any possible situation. Of course, collaborating with other countries, collaborating with other systems always creates more resilience. So it's important to note that. Nevertheless, at the level of Europe or at the level of the US, there is also the intent and the desire to be able to have an independent and fully autonomous system that will not suffer any kind of failure if there is lack of support from a different system. So we are seeing now very clearly a lot of countries investing on their own capabilities. I am based in UK, so this is after UK's exit from Europe, this has become a lot more clear to us. Now, resilience, again, it's, as Dennis said, it's something that is very important because you want to make sure that when something goes wrong, and things go wrong all the time, the system continues to operate. It doesn't fail. So how do I achieve that? There are many ways by having multiple systems. I mean, you can have a very low-cost approach, NewSpace approach, where rather than having one solution, you can have multiple solutions. So one of them continues to operate if something goes wrong. You can have, very expensive solutions with fail-safe systems. It's a matter of choice for each of the deciding party to understand what works better for them and make that decision really. At the end of the day, it all comes down to money. How much money people are prepared to invest in these solutions, and how much resiliency they can afford to have in these systems.
Yeah, thanks. So that's a great answer and probably a good segue into our next topic. Iraklis, I would love to ask you a little bit about space communications infrastructure. And specifically, you mentioned that you're living in the UK. Reflex is based in Germany, but I know that CesiumAstro has offices on both sides of the Atlantic. When it comes to this sort of communication infrastructure, what are some of the challenges that are facing both maybe European and US interests, and how do you propose to address them?
Well, most of the communication infrastructure is of specific interest to defense market, and for us, the defense market has been, of course, very important market, but that it comes with a lot of, let's say, history and a lot of processes which are traditional and very slow. Procedures for procurement from defense organizations they follow a very long pattern. They're expensive, they take long, and of course, by the time that you get to a solution, that solution may not necessarily be the latest possible technology, the most innovative technology in the market, due to the timescales involved. And of course, all of this has a major cost as well. And again, that means that the solution you may end up with is not always going to be the most cost-effective, the most efficient solution. Nevertheless, defense market is important. It's something that we all have a role to play in. The challenges in the infrastructure is, I would say, the challenge is the frequency allocation, the spectrum management. There is a lot of competition for spectrum. It's difficult to manage it, and at the end of the day, we all have to find a way that works for everyone. The two biggest problems I see from my perspective, one is money, so the cost of the processes and the time scale that is involved with that, and the other is management of resources, whether that's spectrum or available assets, space assets, or any other resources. And how do we use them efficiently?
Yeah, so I'd like to come back to the technology part of that and talks about the spectrum. But right now, I know big news in Germany was that a few days ago, the German Minister of Defense announced investments in space defense totaling 35 billion. People are spending more on defense and they're spending more on space. How does that change the situation for startups in the space industry, both in Europe and in the US?
Well, whenever there are large budgets involved, there is a lot of competition. There are big traditional companies that are trying to get access to those budgets because that's exactly what they need to be able to produce something viable. For new space companies that don't actually need such huge budgets, the truth is that it is possible to do a lot more with this money. But I think we still have the issue of having to follow specific processes. I think there is one of the bigger problems also is the appetite for risk and failure. Because without being able to take risks and without being able to accept failure, there is not going to be any innovation. Innovation demands risks, demands failure. And the more appetite we have for failure, the quicker we're going to move innovation. I mean, all you have to do is look at SpaceX and Elon Musk. There have been several failures before that launcher actually managed to land safely. But look at it now. So all this progress would have never happened if there was no appetite for failure. For me, that's a very, very important message for everyone. The huge budgets, of course, they help. They distribute quite well across the industry. But I wish that with those huge budgets, there was an allocation of money for innovation, for new things that will not necessarily be successful, but will teach us how to get to the next step.
Maybe my question would be to Sotiria, like how is CesiumAstro positioned to serve the German or European demand for this type of technology?
Of course, as we mentioned, CesiumAstro, I mean, we might classify it as a startup, but we really are successful in the US in terms of we already have factories producing our antennas, we have designs, they are ready. And that actually came from a similar process in the US, right? Like the system there invested on smaller companies to be able to innovate faster, to bring these products to market, to satisfy some defense related or government missions, but that really helped the innovation, that really helped companies to grow in a very short timeline. And now we have all this knowledge, we have the building blocks. And what we can do here in Europe, we can take all this knowledge and transfer it to this market. So we can even more accelerate this time to get something out and make it, fly. So in Europe, we can have similar production capabilities. We can tweak our products to what the European market might need, even if it's commercial or defense. Anyways, our products are designed to be modular, and that's exactly why we are successful and why we want to be in this market. We don't want to make custom products for every new application. We want to be able to have all the building blocks, and then based on the application and the user need, we put them together, and you have something out of the factory in a very short timeline. So the vision for Europe is exactly that. We want to be able to produce things here. We want to be able to be successful here, and also bring that technology to this market because it's needed, right? Like to be able to move the space communication to the next level.
I think that is really interesting. You mentioned the modular systems, and you talked a little bit about your technology and how it's different than legacy systems. In Earth observation, off-the-shelf solutions are everywhere. They're commonplace, but there aren't nearly as many of these types of solutions for telecommunications payloads. Why is it that it's taken so long to make this a modular system? How did you approach this challenge, and what has it allowed you to accomplish?
Yeah, sure. Like we see that in other industries, and in Earth observation, things might look more standardized or off the shelf, but in reality, they're also more protected and less agile from the regulation frameworks or any other activities. Telecommunication is indeed a little bit different. The demand is pretty much the same, right? Like most of the people want more throughput, more flexibility, but each operator has different mission needs. So one may need a payload optimized for a very specific frequency band. Another might want a very specific coverage footprint to cover their own country or region or whatever. Other people might prioritize traffic and how this is routed through their network. What we do is, as I said before, right, we have a software-defined payload. So there is a big layer of customization that it comes into telecommunications, but we take some of it on our system, And then, of course, there will be a portion of it that you will need to probably customize based on the need. And that's why we have this technology. So we don't start from scratch, and we don't get stuck to, one size fits all. We can grow as big, as more as the platform requires, but we have to have all the building blocks together.
We're talking about resilience. We're talking about these building blocks. Does any of this change if customers are operating a constellation, or is it more or less the same type of model on your end?
I mean, for us, it's similar approach, right? Operating a constellation is a big thing and really changes the game. And that's why we don't see a lot of people or a lot of companies getting there fast. A single satellite can provide limited coverage. When you go to a constellation, you start facing problems of how do I route the traffic? How do I connect my satellites? What happens if one of them gets offline? How I'm gonna, manage the whole and orchestrate the whole constellation, plus all your ground assets, how they're gonna enter the constellation, verify them. You start having some big questions that you need to reply as an operator, and that really creates a new ecosystem of companies that they need to support. For us, what is very important is all this dynamic resource allocation that it happens in the RF spectrum from the constellation. Our system enables to shift capacity where demand is higher. So we have a multi-beam system, so you can point your beams in one area if the demand is higher there, or there is a disaster, there is a conflict zone, a congested area, whatever. You can also hop the beams from one place to the other to increase the capacity and support more system. And that also goes, into the mentality of, okay, if my RF payload can do that, how can I optimize my constellation having less satellites and only, add some of them when it's needed to, increase or replace or upgrade something on the system. So in terms of reliability, that means that you can also have more reliable services in some areas. You can build more satellites in when you need to. You can adapt your services. And that really speaks on this resilience question as well.
Yeah, it makes a lot of sense. With resilience, we're talking about sort of the in-space, the technology aspects of it once it's operating. But another topic that is on everybody's minds is supply chain management. We talk about resilience also in terms of sovereignty and in terms of what level you are capable of producing maybe in-house or where you source the components. So I throw this question kind of to both the CesiumAstro folks, but also Dennis from Reflex. What is the approach to build versus buy? When does it make sense to verticalize components in-house versus source them, and how do you make those decisions?
Yeah, maybe I'll take that one. Reflex's value proposition is speed to market, right? So we have put a lot of effort and work into optimizing our processes to be able to customize a new design of a satellite and bring it to market or bring it into orbit in less than 18 months. And we're constantly working on improving it. Our goal is much more ambitious. But where do we see the bottlenecks and the biggest obstacles along that way? It's the lead time of the most critical items. Payload is typically one of these critical items, but there are also other components in the supply chain that might hinder you from achieving your goal of being very fast in orbit. So for us, that is one aspect of deciding what should we pull in-house to be really in control of that development of these critical components. Our goal is not to produce these components for the market and sell them. They're really only to serve our missions and our satellites. And the second aspect is quality. We are in the NewSpace ecosystem. That also means that here and there you face some performance issues, let's say, in terms of quality or in terms of like ultimately the performance that these components deliver. So we would like to be in charge of that. So for us, it is a big part of our vision to verticalize where it makes sense. However, every mission is different. We are following that tailor-made approach. So it could be that different missions require different types of components, and we cannot build them all. So sometimes we procure if we need, I don't know, like a slightly higher performance, or in terms of communication payload, it's also security is an issue. If the customer wants to have some embedded encryption or security by design, or just needs a very high downlink. So there are certain aspects that lead us either into the buy or into the build decision.
I guess it's for us it's not dissimilar really. Our general philosophy is buy what you can, build what you cannot. It is important, of course, to diversify, make sure that there is duplication sometimes. Which is one of the main reasons we want to expand in Europe. We want to be able to develop capacity and capabilities in Europe, so that we have, if you like, a secondary source of development and manufacturing. But I also agree with Dennis. It's important to know what is out there, to know the value chain, to know the supply chain, and understand the capabilities of each of the suppliers, so that you select the right one at the right time, and of course maximize the efficiency of the whole supply chain.
Makes perfect sense. I think there's another area in which there are some similarities in approach, and that has to do with cybersecurity. I know CesiumAstro and Reflex both take this pretty seriously. Iraklis, you have a background in space cybersecurity. And Dennis, I know we've been focused on projects involving cybersecure communications at Reflex. But I'd love to hear from you first, Iraklis. What does the cybersecurity landscape look like today, and how are you addressing it?
Well, in many ways, it's not dissimilar to any other cybersecurity landscape, Sam. I think if you look at the history of how spacecraft communications have evolved, only a few years ago, there was no attempt to protect the communications links from cybersecurity attacks. And it has been in the past, it has been very easy even for amateurs to intercept and control signals. But the landscape has changed. I mean, all of the space companies now have implemented some form of cybersecurity, some more than others. There is now a European attempt to also advise the industry of how to proceed with cybersecurity. ENISA has released last year a paper which gives some basic advice on new space companies more specifically, because they are the more vulnerable ones, and SMEs in general, not just NewSpace, on how to go about with cybersecurity. There is a significant effort now placed into cybersecurity, and it is increasing all the time. I mean, we are even seeing work towards quantum key distribution and new technologies which make the safety and security of the links very, very robust. So I think this is something that will continue progressing in the same way that it has for the terrestrial world, and it will become more and more secure. I mean, now we know that we're going to need to be updating our satellites in the same way that your mobile phones get updated to be able to tackle cybersecurity issues. So, and of course, it is good that all our payloads have software-defined radios. Many satellites have software-defined satellites now. So this plays quite well with all this effort.
Yeah, this is also part of our philosophy. Software is, how do I put it? If I say more important than hardware in space, that is not right. But the importance grows the further we go. And we are focusing a lot on software. I think half of our engineering team are software people. When it comes to security, I mean, it's a wide field. We mostly rely on external systems. So we produce and developed certain aspects in-house, but the customer requirements are so manifold that we want to be able to, serve every country with their own expectations when it comes to security, with their own standards, with their own systems that they would like to apply. So that is actually one aspect where we rely mostly on external partners and suppliers. And I agree with you, Iraklis, it's growing more and more important, or it's getting more and more important. And we're trying to be ready. I mean, you cannot say as a NewSpace company, yeah, our systems will be proven, right? But we are trying to, take step by step towards reliable systems that are hard to penetrate.
Yeah, I mean, this is a key thing, I think, for both of our companies. And I want to get at, like, what is the landscape? What does it look like right now? Why is it so important that everybody is taking security seriously?
I guess I can take this, Sam. You can see with all the turmoil that exists in the world at the moment, we have the war in Ukraine, we have the Gaza Strip in the Middle East. The attempts to intercept and take control of military assets are becoming a lot more prevalent. So it is important to be able to tackle that threat. And you think of a satellite, a CubeSat in the space that perhaps just takes photographs every now and then, and you're thinking, okay, there's nothing important with this satellite. What people don't realize that CubeSat can become a weapon. If you point it towards another satellite, towards the ISS, that can easily take out very, very important infrastructure. So it is important to understand that the cybersecurity element is not just for the big, expensive military satellites. It's for everyone. Everyone needs to be aware of this and needs to be able to tackle that. So it has, with all the conflict in the world, it is a lot more important to address this issue now.
And if I can add a little bit to that from my side, to build on the constellation concept that we talked before, we see people moving away, like legacy systems where, especially the ones that they had to be cyber-proof, cybersecurity proof, they used to have TMTC, so the control link of the satellite was an air gap network, so nobody had access, it wasn't connected to the network, it was very secure. Now this is changing the whole mindset with the constellations. You have a network, a real network, and that can get information and be updated from several network routes. And you have to be able to protect it from the threats that may be coming from all these, like people that they might want to take control of your satellite, or like push something through your network that you have not authenticated. So encryption, authentication, redundancy, these are very key concepts, and I agree with Dennis. We cannot add them later. You have to build your system from the beginning to be able to be cyber secured and patched, of course, as new threats are coming up. But your whole supply chain, the way you manufacture, all of these, they have to be protected so you are ready when you launch.
All right. I do think that does a great job of summing up why it's so important that we're having this conversation now and what it means for somebody who knows they're going to be taking some assets to space but may not understand exactly what the security risk is, even when you're not a security satellite. So we're coming up on the end of our conversation. I want to give you all the opportunity to share something with the audience if they have to remember one thing from this conversation, what do you think is the most important takeaway from your side?
It is important for the audience to acknowledge that space nowadays plays a major role in everything we do in our terrestrial life. Being able to have a resilient space segment is actually very important. It's we have to be able to build and replenish that infrastructure quickly at low cost and in a way that it's flexible and will serve really the needs of the terrestrial operations at whatever level.
Yeah, maybe from my side, I think like we know CesiumAstro for a while, and we feel that we are very much like-minded. We have big opportunities here in Europe, for and foremost, but also on a global level. And from Reflex side, we are strong through partnerships and through collaboration. We are in a position to tackle some of these challenges that we are facing right now. And there are big challenges coming our way. Space is becoming more and more part of the battlefield. We see us as enabler for customers to get capabilities up in space. We see partners like Cesium as ideal complement partners for the whole system that we would like to roll out and that we would like to provide. And therefore, for me, the signal is clear. Now we have a market that has sufficient funding, that faces the biggest challenges so far. We have a lot of newcomers, new players that are ready to prove themselves. We welcome a opportunity to really prove ourselves. So far, the Americans have shown how to do it best in the SDA approach. It's not a super ideal approach, but it's much better than the procurement processes that Europe has in place. There are big opportunities for Europe to change the way they are procuring and to open the field for new players to also grow and deliver what's needed, like secure assets in space.
And I completely agree with both Iraklis and Dennis. I feel the same. I feel that we have this very good opportunity. All together, the industry is there. The people are there, like the companies exist for some years now, and they're willing to innovate and to move fast, test these new ideas, learn from the failures, and just keep going. The whole system around us has to also get into the same mindset, and that's how we will build also in our region this future in space that we all envision and we want to support.
All right. And I think that's as good a place as any to wrap this up. Thank you so much for taking the time and for sitting in on this important discussion. I hope that for the people listening, you've learned something about the critical communications technology that's forming the backbone of resilient sovereign space infrastructure, and also why that space infrastructure is so important. I'd like to pass it then to Iraklis and Sotiria to say where they can find some more information about your company.
I guess the best place is our website, CesiumAstro.com, where you can find information about our products and contact details where you can contact us really. We'll be happy to respond to any inquiries and whether this is for our standard products or for anything custom that is required.
We also occasionally travel the world, so you might also find us in your region or any of the conferences for space industry. So we publish everything in our website. So I think that's the best place. And our LinkedIn, of course, and social media.
Great. And Dennis, where can people find out more about Reflex Aerospace?
I think one thing about Reflex is we are omnipresent almost everywhere. It feels like we're at every conference. No, of course, our website's the number one go-to place probably. LinkedIn is always a great way to connect. And we also outline the conferences we are visiting. So just send us a message and grab us for coffee.
All right. Well, I hope to keep this conversation going in person sometime soon. But until then, thank you again so much. I think this wraps up the NextSpace session. So thanks, everybody, for listening. And be sure to tune in next time. Take care, everybody.
Thank you, everyone.